using proportions to find equations of exponential functions. True or false? 2 equals 2. That's true. 5 equals 5. That's true. 2/5 equals 2/5. That's also true. If you form a proportion with two equations, you still have a true equation as long as the denominators are non-zero. So essentially, we stacked the two equations up top. 2 over 5 equals 2 over 5. Find the equation of the exponential function whose graph contains the points -2, 3, and 5, 8. Round your quantities to the nearest hundredth if necessary, but only round in the very last step of the problem. Using the exponential model, y equals ab to the x, plug in the point -2, 3, since that point has to satisfy the equation. Then separately plug in the point 5, 8, since that point must also satisfy the equation. You'll get 3 equals ab to the -2, and 8 equals ab to the 5th. Then form a proportion with your two equations, using the equation with the greater exponent as the numerators. You'll get 8 over 3 equals ab to the 5th over ab to the -2. Notice that there are some things to simplify in the right-hand fraction. The a's cancel out and the b's simplify. You'll get 8/3 equals b to the 5 minus a -2 from the properties of exponents, and when you simplify that, you'll get 8/3 equals b to the 7th. Now b needs to be isolated. A reciprocal exponent applied to both sides of the equation will be useful. We had b to the 7th. The reciprocal of 7 is 1/7. Get the value for b using your calculator and leave the result on your calculator. Do not round right now. You should get a b value of about 1.150, and then it goes on from there. Substitute the b value you just found in one of the two original equations. I'm choosing the equation with the positive exponent in it. That equation was 8 equals ab to the 5th. And then when I do the substitution, I get 8 equals a. I put in 1.150 ... to the 5th power. I don't do any rounding yet. I'm going to isolate the a value using division. And when I do that, I end up dividing both sides of the equation by the 1.15 quantity raised to the 5th. And we still haven't done any rounding yet. We're going to use the calculator and the previous answer feature to solve for a, so that we are not using any rounded values. You should get an a value of about a equals 3.970, and it goes on from there. Now that you have your a and b values, you can round them to the nearest hundredth at this point, construct your final equation, and check to see if it's reasonable. The equation that we get is y equals 3.97 times 1.15 raised to the x. This equation indicates that the y-intercept of the graph should be 0, 3.97, and that the graph should increase since the b value is greater than 1. Check this based on the points that were originally given. Plot the original points and put in the graph of an exponential function containing them. This graph is increasing, so the b value is reasonable. A y-intercept of 0, 3.97 is also reasonable. The point that we knew to the left of the y-axis had a height of 3, and the point that we knew to the right of the y-axis had a height of 8. So we know our y-intercept needs to be between 3 and 8, and then the graph that we drew in shows that the y-intercept is less than 5. So ours is reasonable. The equation can also be checked algebraically by plugging in the original points one at a time to see if the equation holds true. Remember that the rounded values may keep things from checking out exactly perfectly. The equation could also be checked using exponential regression.